Welcome to Goldfish on Games, and today we release MegaAtoms version 0.2. This includes a whole bunch of new animations to help guide players, including idle, critical, and various animations for when the atoms grow. This should make the whole game grid seem far more vibrant, as well as give players a slight indication of what they could be clicking on. That has also been helped by the fact that there's now a tutorial in the game. It's found from the player select screen and gives you a rough idea of what you should be doing and how many atoms can be in each of the grid squares. It's not going to explain everything because it's a game that you should try and learn, as I did back on the Amiga. On top of that, there's been a whole bunch of bug fixes. This includes some of the weird graphical glitches, as well as a few of the issues with audio and some of the items not showing up correctly. Hopefully you'll enjoy the changes, and let's have a much more detailed look at what's changed. I really do like those animations. They really do make that screen pop really well. And hopefully you'll be able to go off and grab it straight away. But if you want to hang around for just a few more minutes, I want to talk about how I went around taking the graphics from the original image, getting them in the MegaDrive, and then eventually drawing them on screen, as this became quite the talking point in the last video in the comment section, and I felt that I could do a much better job by trying to describe it in this video. Let's take a quick look at the image that we're using on screen, and it's this. A 144 by 1008 pixel sized image with every single frame of animation for every single color type. This is using 16 colors and is 2,268 tiles in size. Amazingly, this is actually more tiles than the VRAM can actually handle. So we're actually going to have to come up with a way of compressing that down so we can fit it in memory. The best thing is the MegaDrive has some of these things built in, and the best way to show it is through a simplified image. Here we have the tile set we use for the 0.1 release. It's only 144 pixels by 144 pixels and gives us 326 tiles. Now what we can immediately notice is there's actually a lot of duplicated tiles. The bottom half of the atoms as well as the top left hand corner tend to be the same across the rows, and thus we can actually remove those from the set. We can also look at removing mirrored or flipped tiles as well that match up. Doing this gives us a new tile set which is 128 pixels by 88 pixels and gives us just 163 tiles. This is a huge saving, almost half the number of tiles that we need to put into the VRAM. But this is no longer an image we can directly show on screen. We need an intermediate format to give us the information we need, and this is the map. Here we can see a cell for every single tile in the original image, and if we look at the first 6, that matches up to the first 6 in the image as well, and the 0 there lines up with 0 in our new tile set. If we look at the next set, it lines up with our atom, and we can see that we use tile 1 and then tile 2, but the third one is a very unique number. It's actually there to tell us that the tile is actually going to be mirrored, and it's going to be using the very first tile, or tile 1 I should say, but in a mirrored way. And then the next row moves on to 9, 10, 11, 21, 22, and then we get another special number which is actually another mirrored 21. And you can see here already how we're managing to save a huge amount of space. So how are we drawing this on screen? Well, we have our layer B, which is our background with the grid. We load the tiles and the map in directly into the VRAM and draw it. No messing around, nothing we really need to do. What we then do is have layer A on top of it. Now I actually offset it just to make things a bit easier, and this means I can just draw to the top left hand corner and move on, and I know all the atoms are going to be in the right place. Into layer A, I then load my simplified tile set. If I wanted to draw the first atom, I'm going to have to look up that information in the map, as we did before, and then draw that to the screen. I have all the information needed to draw any of my atoms on the screen in any of the grid squares, because all the information is there in the map. I just need to index the right area. So when I go to draw, I just go through each grid square, look up its information, and draw what I need to the screen. This information is stored in a simple structure, and I have 70 of them because we have a 10 by 7 grid. Here we can see we have animation flags, what frame we're on, how long we need to wait to the next frame that needs to be animated, the player color, the size, and a few other bits and pieces to work out what we need to do with this grid square when we're animating. To do the drawing, we have this relatively simple function. The top 3/4 is handling the animation. It looks up how many frames it needs to animate for, if it's looping, and a few other bits and pieces, to then work out which frame it should be trying to draw. This information is then passed on to the final bit of this function, where it will then index into the map, pull out the right tile number, and then draw that to the screen. And in this instance, drawing to the screen just means updating the screen map for layer A. Hopefully that was a little bit more descriptive than what I put in my previous video, and what I tried to then explain in the comments. Talking about the comments, if you have any ideas or suggestions for where the videos should go, or MegaAtoms, leave them in the comments here. Or you can catch up with me in the Retro Game Dev Discord channel, which the link is also in the description. We've started that up as a way of trying to get the whole retro game development community together and give them somewhere that they can chat, both in private as well as in public with everyone, to help each other move forward and get more chat and more information out there, as it can be a little close-knit at times. So if you want to know more, follow the link, or you can like and subscribe this video, and I will be able to put out more information as it comes up. So until next time, I've been the Goldfish, this is MegaAtoms, and I'll see you next time.